Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Following the stack based design pattern, today we'll do the second question, which is implement stack using queue. In previous video we already did implement queue using stack, and today we'll do the vice versa question. So let's read the problem statement. As you can understand from the problem name itself, you have to design the stack data structure with the help of queue data structure, and functionality will be as it is. So suppose you have been given elements like, to push you have been given 1, 2, 3, and then you have to call pop function, then again push for let's suppose 4, then again pop, correct? So what is the behavior of stack? You have to design stack, right? So when you insert in stack, you always insert from top, and when you pop, you get the topmost value as popped, correct? But in queue data structure, it's not so. Why? Because in queue, you insert element from one end, okay? Suppose 1 you inserted. Now you want to insert 2. So 1 will move forward like upward, and then 2 will get inserted, correct? Now if you want to insert 3, you have to move this 1, 2 upward and then 3, okay? So means if you want to insert, means insertion is done from one end, and when you want to pop, means pull, you do from the other end, okay? So means whatever has been inserted first will get out first as well. So it follows FIFO structure, means first in, first out, correct? So with the help of queue data structure, how can we design stack data structure? Let's try to break down. Suppose we have inserted 1, 2, 3, correct? But now if I will pull from this queue, let's say it's Q1, okay? Then definitely we are going to pop the first element, which is 1. But I am looking for third, correct? So it's for sure we have to reverse this. Can I say? Yes. So means we need one more queue, correct? Q2, as we already did in the stack 1. But you know what? Here the simple logic will not work. Why? Because when you will pop 1, it will again get inserted here 1, correct? But what element you want? You want 3, na? Wait. Now when you will pop 2, it will again get inserted below. Now you will pop 3, again it will get inserted 3. So you to decided to take Q. Why? So that you can reverse it and you can get the top element. But again 3 has been inserted at the end. Now if you will do the pop operation from Q2 also, you will get 1 as the top element, not 3. Then how to do this? So the idea is very simple. Definitely we want the reversal of it, correct? So there are 2 ways. Remember, very first way is where insertion takes O of n time complexity, okay? So the rule is very simple. Definitely we want another queue to reverse our elements, correct? So whenever we try to insert something, first we will insert at Q2, okay? Why? Because we are designing our queue such that the recent inserted element will somehow come at the top element, okay? So we will insert at Q2, and then we will check if we have any such element in Q1. Till now we don't have, okay, it's okay. So now we can remove this 1 and put it here, correct? And all pop or peak operation, or you have to check the empty or not, that we will do with Q1. We are only taking help from Q2 just to put the recent element at the top. But with 1 you didn't understood this. Let's try to understand when we will push another elements. So first we will push 2 here, correct? As our elements, previous elements are sitting here, this is 2 here, correct? So I can say now my top element, like what I wanted, my top element to be at the top, correct? But if as per the Q rule, if we have inserted in Q1, then it would have inserted below, correct? Yes. And we tried also putting every element here, still we got the same rule, 2 below, but we want at top. So what I am saying, whatever elements you are inserting in any data structure, which is Q2 of course, so try to keep it empty. So when you will try to keep it empty, definitely that element will come at top, correct? And now whatever leftover elements are there, which is in Q1, because you copied earlier, right? Now start popping from here and start putting here. So now you will see, you will pop 1 here, and this 2 will come above and then 1. And now you can say, na, ki yes, 2 is at the top, correct? So we will just copy like 2 and 1 in the same position in Q1, not in Q2, because Q2 we are always keeping it empty just to insert the newly come elements. Okay. Now suppose 3 comes. So obviously 3 you will insert here, and now whatever is there in the Q1 you will remove from here 2 1, and then 2 1 will get inserted here. So can I say it's in order 3 2 1? Yes, it's in reverse order, right? And what is the top element? 3, correct. So what I said, from Q2 we will not pop, because Q2 we are always taking empty, to bring our top elements, like recent elements at the top. So now whatever is in the Q2 we will just copy paste in Q1. So it will become 3 2 1, and now again Q2 will become empty, correct? Now if you have to do any pop operation, as you can see after 3 we will do pop. So that we can do from the Q1. Why? Because insertion we do from one end, but the pop we will do from the top element, right? Like top side. Then definitely we'll get 3, and now it's behaving like stack instead of queue, isn't it? Yes. But the thing is, why I said ki like push operation is taking O of n time complexity, because as you saw, suppose we have to insert 4 now, so we will insert 4 here. But now we are running a for loop to copy, like to pop every such elements from here and push it here, so that this will become 4, then 2, and then 1. And again we are copying everything from here to here, 4 to 1. That is actually taking O of n time complexity when we are pushing elements, like when we are doing the push operation, correct? But for popping, peeking, we'll simply do from this top element, that will take only O of 1 time complexity. So whatever discussed, let's code for it. So first here we will make like we have to declare the queue globally. So first we'll make queue of type integer. Let's name it q1 is equal to new linked list for q1 and for q2. Okay, so let's name it q2. Okay, now we have to do this push operation. Remember, this is to declare our q1 q2 data structure which we are using, but I have defined globally here, correct? Now we have to do push. So what I said, in q2 we will offer, correct? So q2 dot offer, first we pushed in q2 the x element, correct? After pushing we run a while loop, correct, until the q1 is empty. So until q1 dot is empty, correct? Until our q1 is empty, we will poll, like we will pop from q1 and push in the q2. So q2 dot offer whatever we are popping, which is polling from q1, correct? After this we will get, like in the q2 the recent elements will be in the top and rest onwards. Now we'll just copy paste into q1. So we'll write q1 is equal to q2, and now we have to make q2 as new linked list, and now push done. For pop, as said, we will do pop, peek, everything from q1. So we'll just return q1 dot poll, correct, because it's pop operation. For top means we just have to read the value, so return q1 dot peek, so it will just read the top value. If we have to check empty, so we'll return by checking if q1 dot is empty. Why? Because we are just using q2 for the push, and in the same operation we are just copy pasting everything from q2 to q1, correct? So hence q2 will always be empty after the push operation. So hence we have to like take care for q1 and not q2, correct? So now we can run the code, and definitely as you can see it's running, so we can submit also. Obviously it's optimized, but the thing is key here, the push operation is taking O of n time complexity. So we will try seeing how we can optimize it further, the push operation can we do in just O of 1 time complexity. So let's try to do that, like optimized O of 1 for push operation. So idea is very simple, guys. I loved this one, the second one which we are doing right now, because it's more easy to understand, First we will push 1, correct? After push 1 we will push 2. After pushing 2 we will push 3, correct? So this is how it will look like. But when we will pop, we will get 1, but I want 3, correct? So what was the idea? Why we do Q2 data structure? Only to keep this 3 on the top. So in the previous one we inserted here so that it will be on top, correct? In this one the idea is very simple. We are popping every element from here and we are pushing it here, correct? So when we will poll, 1 will come here, correct? Now when we'll poll 2, so definitely 1 will move ahead and 2 will come here, correct? Now wait, what was the idea? To keep 3 at the top. So this we can do here also, na? You know, means poll everything except the last element. Now it will be on top element only, correct? But this we will not do when we are doing the push operation. Means when we are doing push, we'll simply push in Q1. Whenever pop operation or peak operation, like what's the top value, whenever there is anything related to top value, in that condition we'll move n minus 1 elements in Q2 just to keep this last element in Q1. If it's pop, remove from here. If it's push, read it and then again put it here, correct? Why? Because after this now our next job is to just make the copy of Q2 into Q1 and again make Q2 empty. I hope it's clear. Okay, so let's write the code for this as well. So this was our previous code, right? So when we are pushing now, like we will simply push in Q1. We have nothing to do with Q2. Simply we'll push in Q1. When Q2, like when pop operation comes, we will pop everything from Q1 and push into Q2. So what we'll do, while we'll run a while loop, while our Q1 dot size, now we will not check if it's empty or not. We'll check if its size is greater than 1. Why? Because we don't want to pop the last element, remember? Yes. So what we'll do, in Q2, we will simply offer whatever we are popping from Q1. Done? Yes. Now after coming outside, we want to read the last value. So we'll store in val and Q1 last value, right? So now we can do Q1 dot poll, correct? And now definitely we can return value, but we have to copy paste Q2 into Q1, right? So we will do Q1, whatever is there in the Q2 now, just put it back and again make Q2 a new linked list. Okay, yes. So in this way, like whenever we are popping na, then only we are changing this. So the same thing we can do for top element as well. The only thing is, instead of polling the last value na, we will just peek it, means we'll just read it, that we will return. And after coming outside na, like see, last value we have read it and now our job is to put into Q2 back. So again an extra line code here. So Q2 dot offer the last element, which is value, correct? Because we don't want to lose it, right? And in is boolean, obviously we have to check as per Q1 only and not Q2, because when we are pushing or popping, we are just maintaining the same. Okay, did I miss something? Oh my bad, why not? Okay, I thought of writing it like is empty check, so that's why I did. Yeah, I removed. Achha, okay, we copy pasted here as well. Okay, so now it's running. So we have submitted this code, and if we talk about the time complexity, in the previous one, definitely the push was costly, O of n, but pop and offer, pop and top element peaking was taking O of 1. But in this one, push is, it's optimized, but other options are taking O of n. Okay, so means both solutions are valid as per the requirement. You can say ki if we want push cheaper and optimized, definitely I would like to go with this. But if our popping conditions are, the priority, definitely we have to go with the previous approach, correct? So I hope you understood both the approaches. This was your Java code and here is your Python code, correct? With a similar approach, the second one where push is cheaper. And here is your C++ code if you are from C++ background. So I hope you understood both the approaches and both are optimized definitely. But the condition is in one push is optimized and the other one pop and offer. No. And the other one pop and top elements are optimized. So if you understood, definitely we can go in the sheet and we can mark the second question as done. And I hope you are understanding the designing based questions using stack and queues as well. Now in the next video, we will learn about how to maintain the minimum and maximum value with the stack. That is very important. You know, from the interview perspective also, it's very important. So stay tuned and please subscribe if not yet subscribe. And if you understood the solution, both solutions, then do like the video and comment down only if you submit on your own. And that's it for this video. Let's meet in another video with some more interesting topics and questions. Till then, keep learning, take care of yourself and your family.